السلام عليكم.
عليكم السلام ورحمة الله وبركاته.
الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Let's start. Yes, the last thing I was talking about is the Lewis dot symbol, and then we're going to have Lewis structure. Lewis structure, and we know the Lewis dot symbol, for example, for carbon. What's the Lewis dot symbol for carbon? Get your periodic table. And what's the dot symbol for sulfur?
6 electron.
6 electrons around. You don't have to write the 6 electrons, but I just want to show you what are we doing. Now we want to do the structure of CSS. And the first thing we do, we make one bond between the carbon, the S, and the other S. Then we count the total number of valence electrons or dot symbols, which is 1 of this one and 2 of this one. This means a total of what? (12 plus 4 is 16 electrons. I'm trying to calculate the total number of valence electrons. And then, which is 4 from carbon, 6 times 2 from sulfur, 12 plus 4 is 16. I always like to make it 8 pairs. 8 pairs. Why? Because it's easier to count. So this is 1, 2. I already used 1, 2 pairs, 3, 4, 5, 6, 7, 8. And that's it. I cannot add any more because that's all the electrons that I have. That is all the electron pairs that I have. Is this acceptable structure? It's not acceptable structure. Why?
Because carbon is have 4.
Because carbon have only 4 around it. I want 8 around it. What is this rule called?
Octet.
Octet rule. Octet rule. I want octet rule around it. So what can I do? I just can take one of the pairs, like this one and this one, and put it here and here. And now everything has 8 electrons. Is this easy? Yeah. Good. Let's hope so. Now, let's talk about Lewis structure and the formal charge. Formal charge. Formal. What's the meaning of formal? Do you know in Arabic?
رسمي.
رسمي. All right. Formal charge يعني الشحنة الرسمية. All right. Good. What do I mean by this? Let's take an example. For example, I want you to draw the Lewis structure for CO molecule. Go ahead. Draw it. Do it yourself. Don't forget. How many electrons? How many valence electrons we have for carbon? How about for oxygen? Hello?
Hello.
10 electrons. How many pairs?
5.
5 pairs. All right. Do it and draw the Lewis structure for CO. Done? How did you do it? As I said, First thing, put the two elements, C and O, and put at least one pair. Done. You have 5 pairs. So what I'm going to do, 1, 2, 3, 4, and 5. Is this acceptable?
No.
Why? Because carbon has only 4. What should I do? I should take this away, and then put it like this and like this. Done. Is this clear? That's easy. Very good. Now, let's concentrate. Let's consider, as we said here, when we have the carbon bonded to the oxygen, there are 3 bonds between them. I can draw them other ways. I can say C and then O I can draw it like this, right? And each 2 is actually a bond, but I'm not going to draw the bond. I'm going to make it like this, as if I separated the electrons like this. Clear? Very good. Now let me ask you a question. To start, what was the valence of carbon?
Was
4.
4. But how many electrons around it now?
5.
5. This means what's the formal charge on it? It was 4 and now it's 5. What's the formal charge?
-1.
Yes? Say it out loudly.
-1.
Yes. -1. Why -1? Why are you saying -1?
Because it gets 1 electron. Yes.
Exactly. Then what will be the formal charge of oxygen?
+1.
Do you know how to make the formal charge now?
Doctor,
Yes.
can you repeat the formal chart? I didn't get it.
I will repeat, no problem. Okay, I'll repeat it with another. Look at what I'm drawing and understand it very well, or try to understand it. We will go to another example. It's the same thing. We'll do the same thing, but with something else. Let's take, for example, SO3 is O3 2 minus. All right, I want you to draw the Lewis structure for SO3 2 minus. Again, how many electrons do you have for sulfur? How many electrons the valence? Okay, how about oxygen?
Also 6.
8
Times what?
times 3.
Which is 18. And we have extra 2 electrons. What's the total?
26.
Okay, go ahead and draw the structure. As I said, oh, this means how many pairs?
13.
13 pairs. Very good. As I said, to start, I will put S, 1, 2, and 3. And then put O, O, and O. How many I used already?
3.
3 pairs. 3. Okay, so what I'm going to do now, 3 pairs, this means 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. All right? Is this clear?
Yes.
Okay. I already did the formal chart. I mean the Lewis structure, sorry. The Lewis structure. Now, I want you now to put each bond as a dot. So I will repeat the whole structure. This is the sulfur. And instead of putting a bond, I will put one electron here, one electron here to the oxygen, and then I'll put the 3. And one electron here, one electron here, and this is the oxygen. And again, and one here, and there is oxygen, and then I have extra pair here or 2 electrons in the sulfur as well. Okay, so what I did, I just made, instead of the bonds, I made them as dots. Now, is this the right structure? Are you following the structure? Okay, good. Now, are you following what I'm doing? As I said, the bonds, which is this one, I made it as electrons. Now, let's take this electron. I will call this one oxygen 1, oxygen 2, oxygen 3, and the sulfur. Now, in oxygen 1, how many electrons around the oxygen?
7.
What's the formal charge? What?
minus 1.
How about this oxygen 2?
Also minus 1.
Very good. How about oxygen 3?
Minus 1.
Also minus 1. Very good. Now let's concentrate on the sulfur. What's the charge on sulfur?
Plus 3.
Look carefully. As I said,
Plus 1.
Plus 1.
Yes. This is pair, so it's 2 electrons. So this is what? What's the sulfur? Plus 1. Clear? Okay. What's the formal charge? What's the charge in the whole molecule? Add them. What do you have? You have minus 1, minus 1, minus 1, and plus 1. What's the total?
Minus 2.
Minus 2, which is this one. So you are absolutely right. It is the minus 2. Do you know how to do the formal charge? Any question?
Yes.
Okay, good. Now,
Doctor,
yes.
could you please know why oxygen have minus 1 in formal charge?
Because what was the number of electrons in oxygen to start with before it is bonded? How many?
16.
That's 6, right?
Yes.
Now, how many electrons in it? 1, 2, 3, 4, 5, 6, and 7. This means what happened? It gained 1 extra electron. This means it's minus 1.
But there is another one there.
There is another one where?
Around H.
Around H.
No, sorry, this is plus 1. Yeah.
I'm not following. What's your question?
Okay. I thought it's 1 electron, but it was plus 1, not H.
Oh, of course. Yeah, of course. Yeah, okay. All right. Let me now tell you something. So what I'm going to do now, I'm still working with I'm still working with, I want to take this away. And I want to do it one more time. And I want you to help me to redo it. One more time. We are still dealing with SO3 2 minus. I'll keep the structure and I will redo it now one more time. This is the S, as I said, and we put a pair here, and then 1, 2, and 3, and then we put oxygen here with 1, 2, and 3, the other oxygen here, 1, 2, and 3, the other oxygen here, 1, 2, and 3. So what I did actually is I took away all the bonds, I made them in, in another way. And then what's the most important thing? I will write this one now. What's the charge here? This is -1, this is -1, this is -1, and this is +1. All right, and what's the total in the whole molecule?
-2.
Well, how did you find that? By simply adding the numbers. -1, -1, -1, and +1. This is -2 altogether. Is this clear?
Yes.
Good. Now, is there another way to draw it? Yes, there is another way to draw it. I'll take also this away so that we have more space. And I will do it the other way, which is S O O O okay. I'll tell you that later on about this one. No, let's do it from now. It's okay. Okay. Do it from now. Okay. I can also draw it this way. If I draw it this way, okay, and there is 2 electrons extra here. This is also acceptable, but in this case, we will have 8 electrons around this oxygen, 8 electrons around this oxygen, 8 electrons around this oxygen, but we have 10 electrons around the sulfur, and this is acceptable. We will talk about this after a short period of time. But at this time, look at it this way. Now, I'll try to find the formal charge. So what I'm going to do, I'll just put 2 dots here, 1 dot here, 1 dot here. This is the oxygen. And this is the other oxygen. And there is the other oxygen like this. Okay, what I did, I took the bonds and make them dots like this. Now, what's the formal charge? I'll call this one oxygen 1. No, I'll call this one oxygen 1, oxygen 2, oxygen 3, and sulfur. What's the formal charge on oxygen 1?
0.
0. Why?
Because 6 electrons.
Because 6 electrons, and it was to start with 6 electrons. What's the formal charge on oxygen 2?
-1.
-1. Yes, it is -1. What's the formal charge of oxygen 3?
-1 also.
-1 also. Yes, you're absolutely right. How about the sulfur? What's the formal charge on sulfur?
+2 or no.
Count.
-2.
Count.
6.
+1.
No. Wrong.
0.
Yes.
Plus
No. Look,
0.
count. How many electrons around it now? It is
6.
0. Exactly. There are 6 electrons around it, so it is 0. All right. Now, what's the total charge in the whole molecule?
-2.
Minus what?
-2.
Exactly. Why? Because -1, -1, 0, and 0 is -2. Exactly. Okay. Now, these two structures are correct for SO3 2-. Which one is better? The one that contains more zeros is a better structure than the other structures. So which one? I will call this one structure A and B. Which structure is better? A or B? The answer is A. Why? Because you want to make the structure with less charges. The less the charges, the better the structure. What's the difference between structure A and B? Look at the charges. What's the charge on sulfur in A? Hello?
0.
What's the charge in sulfur on B?
+1.
What's the charge on oxygen 1 in A?
-1.
And what's the charge on oxygen 1 in B?
-1 too.
No, it was in number 1, it was in A, was it -1?
0.
It was 0. So which of these structure, which is better, A or B?
A is better.
Why? Because
But it's less charge.
I want you to know this word, very important. Listen carefully. There is what? Less separation of charge. Write the word and memorize it. Less separation of charge. The less the separation of charges, or the more zeros we have, this means it's a better structure. Is this clear? Very good. Let's do this. Now, very quickly, let's determine the formal charge on each molecule in here. This is the structure of NO3 minus NO3 minus. I'll call this one oxygen 1, oxygen 1, oxygen 2, and oxygen 3. What's the formal charge on nitrogen to start with? Nitrogen. What's the formal charge?
0.
No? Wrong.
3.
What was to start with? What's the formal? What's the number of? Valence of nitrogen?
5.
Okay. How about oxygen? We know this. What? 6. What you should do to know the formal charge? Make, instead of bonds, make it dots like this. Okay. And then you have these two, and this is the other oxygen. And this is the other oxygen. So what's the formal charge on oxygen 1? Oxygen 1.
-1.
-4.
-1, yes, it is -1. How about oxygen 2?
-4.
Minus what?
-1.
-1 also. What's the formal charge of oxygen 3?
0.
0.
0. Yes, it is 0. Okay, how about nitrogen?
+1.
+1.
Yes, why +1? We have how many electrons now?
Lose 1 electron.
It lost 1 electron, so it is +1. What's the formal charge in the whole molecule?
-1.
-1. Why? Because -1, and total of -1, which is this one. Fantastic. I hope this is clear. Good. Now, let's have these structures. Okay? Let's draw the Lewis structure for these 2 structures. All right? And then if you draw the full Lewis structure, we want to see which one is better, this one or this one. And I'll give you the structure. I want you to tell me now what's the formal charge. Of course, hydrogen is 0. It has 1 electron and it's still 0. No changes at all. And this hydrogen is 0. This hydrogen is 0. This hydrogen is 0. What's the formal charge of carbon? This carbon. What's the formal charge?
+1.
-1.
-1.
Decide, +1 or -1?
It lose
-1.
-1.
-1. Why? As I said, make the bond, instead of bonds, make it dots. And the carbon is 1, 2, and this is 1. So what's the charge? Carbon, we have 4, but look at the dots around it now. We have 1, 2, 3, 4, 5. So it is -1. How about the oxygen? What's the formal charge?
+1.
Last one. Exactly. How about this carbon? What's the formal charge?
0.
0. Thank you. And how about this oxygen? What's the formal charge?
0.
0.
Oh, 0. Very good. So if we call this one structure A and B, which one is better, A or B?
B.
B is better.
Why?
Because it has no charges.
It has no charges. No charges, exactly. Very good. Now, let's talk about something else. Resonance. Resonance. What's resonance? Resonance, I'll tell you. For example, let's draw the structure of CO2 molecule. CO2 molecule. I want you to draw the Lewis structure of CO2 molecule. Again, carbon has how many electrons? How many
4.
valence? 4. Oxygen
6.
times 2. Total.
12.
All right. Now we draw this before. How are we going to do it? We can. 16 electrons. How many pairs? Right. I use 1, 2, 3, 4, 5, 6, 7, 8. So I use the 8 pairs. Is this the right structure for CO2?
Yes.
Yes, very good. Now, I'll do something else. 3, 4, 5, 6, 7, 8. I already used the 8 structures. Is this a good, another structure for CO2? The answer is yes. Is there any other way to do it? Yes, you can do it. See, 1, 2, 3, 4, 5, 6, 7, 8. All of these structures are correct structure. We did not move the electrons, but we moved the electrons and all of them make the same structure. We call this resonance. Resonance. Don't forget the name, write the name and memorize it. Resonance. What's the meaning of resonance? If you can, without shifting the atoms, we did not shift them. What we did is just shift the electrons, and we can, in this case, find the more than one structure. So for CO2, we have 3 resonance structures.
But the bond's not equal in strong.
What?
I mean, the bond, it's not equal in strong.
When they are,
It's not.
they are actually
It has the same.
Well,
Yeah.
we'll talk this later on, not even in this chapter, next chapter. We'll talk about this later. But resonance means just motion of electrons. Which one of these 3, I'll call this one structure 1, 2, and 3. Which one is the best?
The first one,
Why?
because it has no charge.
Look at the formal charge. What's the formal charge on carbon in structure 1?
0.
0. How about oxygen?
Also
Zero.
0. And the other oxygen?
Zero.
0. How about the carbon structure 2?
Zero.
Also 0. Thank you. How about this oxygen? This oxygen in 2. What's the formal charge?
Minus one.
Tell me, what is it?
+1.
Yes, I need
Plus
this.
one.
+1. Yes. What's the formal charge on the other oxygen?
Minus one.
-1. Very good. What's the formal charge in, now we are 3?
0.
0. What's the formal?
Minus one.
-1. And to the left?
Plus
Plus what?
1.
+1. That's why, which one is the best?
Yes.
That's good. Are you done? Are we done?
Yes, yes.
Now, let's do the structure of NO3 minus. NO3 minus. I want you to do it yourself. Now, go ahead and use your pen and paper and draw the structure of NO3 minus. And I will take this away so that we can know if we have resonances. Draw the structure of NO3 minus and tell me if there is resonances or not, and tell me how many resonances we have. Don't. What's the formal charge of nitrogen?
5.
5. How about oxygen?
6. Minus one, it will be times 3, yes.
Which is what?
18.
18. And then -1, a total of what?
22.
20,
26, I mean.
Oh, 24. It's not 26. 24, isn't it? 24. Yes. Okay, go ahead. Draw the structure. Oh, 24, this means how many pairs? Okay, as I said, to start, put nitrogen, nitrogen, oxygen, oxygen, and oxygen. I use 3 pairs.
Doctor,
Yes,
why is it 24?
Hatem.
I think it is 22, Doctor.
Please. The -1 is not. This is this is you add electron because it's minus. If it's minus, you add electron to it. Not minus.
Okay.
Sorry.
Okay.
If it's plus charge, then we make it. We take electron if it's plus charge, and we
Okay.
add electron if it is minus. Oh, okay, okay, got your point. Okay, when it's minus, this means we add electron. When it's plus, then we take the electron. Is this clear?
Yes, yes.
Yes.
Now 24, and to draw the structure, I can do it 3, 4, 5,
Each panel has 2 bonds.
8, 9, 10, 11, 12. It's exactly like this. Okay, can we draw another Lewis structure? I mean, resonance structure.
Yeah.
How?
Yes.
How? That's another resonance structure. Can we draw a third resonance structure?
Yes.
How?
Put the pairs
Where?
fork.
Yes. Can we draw another structure?
Yes.
Go ahead.
Make all the O's share double pairs.
No, you cannot,
Why?
because there will be big separation of charges. We'll talk about this in a while. Actually, you cannot make
Make it all the one pair.
what again?
Make it all 1 bounce, and the nitrogen have 1 bounce.
Okay, very good. That's a good point. Let's look at this structure. And count the pairs, by the way. I wanted to count the pairs. Is this the correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is this acceptable structure? Last one, which is 4. Structure 4, is it acceptable? Is it acceptable?
No.
No,
No.
because nitrogen will have 6.
This is wrong. So we have only okay. We have only 3 resonance structure. Is this clear? We have only 3 resonance structure. We have no others. Is this clear? Good. Okay. Draw the possible resonance structure for sulfur trioxide. And this is the structure, sulfur trioxide. How many structures we can make out of this one?
2.
2 more.
2 more,
3.
yes, 2. 2 more, which means what's the total?
3 reasons.
Yes. So this, and the other one is there any other structure? No other structure.
So the difference only the 2 bonds.
Exactly. We move the double bond. We move only the double bond. Or if it's a single bond like what we did with CO2, if you remember, oh, we took it away. We cannot we move the bonds without moving the atoms. That's the meaning of resonance. The word resonance, move bonds, but keep atoms in the same place. Clear?
Yes.
Okay, now, is there exception to octet rule? What's octet rule, by the way?
Euler.
Rule. What? What's the meaning of octet rule?
After 8 elements, the element will be the same.
8 what?
After 8 elements.
No. No, what's the octet? Lewis, octet rule. Oh, you have to memorize this, very important. What's Lewis octet rule?
Every atom want to has 8 electron.
Surrounded, exactly. The atoms would like to have 8 electrons around it. That's the meaning of octet rule. That's why when we draw the structure of CO, for example, that was the structure of CO. Now, how many electrons around this oxygen? The oxygen, how many around the oxygen?
8.
And how many around this carbon?
It's also 8.
8. And we have 8 electrons to start with, and everything is okay now. Is this clear? Now, can you draw the structure of NO minus?
Yes.
Go ahead, draw the structure of NO minus. Again, how many electrons do you have for nitrogen?
5.
5. How many for oxygen?
6.
6.
6. And we have extra electrons, so I'll put +1. What's the total?
11.
12.
12, sorry.
12. Put them. Nitrogen, 12 means how many pairs?
6.
6.
Okay, and then we'll put it 1 and 6. 1, 2, 3, 4, 5, and 6. Okay, that is NO. NO molecule is like this. Is this acceptable? Yes, it is acceptable.
Yes.
Very good. And there is a minus charge. What's the formal charge on oxygen?
0.
0.
What's the formal charge of nitrogen?
-1.
Minus. As we said, we have 6 electrons now around. It was 5 only to start with. So what's the total? -1 and 0. What's the total?
-1.
So everything is okay. Is this clear? All right. Now, how about if we have, I want you to draw the structure of NO molecule. Can you draw the structure of NO molecule? What's the number of electrons in nitrogen?
5.
How about oxygen?
6.
How about the total?
11.
How many pairs is this?
Mm.
5.
It will be 5.5, right? That's why if you have the total number of electrons is 11, you can never draw the octet rule. You can never apply the octet rule. Is this clear?
Yes.
Very good. Let's try it. We will have N.
Must be even number.
Exactly. O. And then 1 electron here. So how many electrons? This is the structure of NO. NO without charge. How many electrons around the oxygen?
8. 6.
Okay, and how many electrons around nitrogen now?
7.
7 only. This means if you have odd number of electrons, odd total number of electrons. What does that mean? You cannot draw or make the octet rule. Is this clear?
Yes.
Okay, I hope so. I hope so. This is now clear. That's
Can you repeat it again, Doctor?
if you have the total number, odd number, what does this mean? It's not even. This means you cannot divide it by 2. This means you cannot, if it is odd number, you can never make the octet rule. Clear?
Okay.
Very good. Now, next, incomplete octet. 2 elements in your periodic table. Look at your periodic table. B, E, and B. Look at them in the periodic table.
Yes.
Okay, where are they?
2 and go with 3.
Okay. BE does not like to apply octet rule. Octet rule does not apply for these 2 elements. This one would like to have only 4 electrons around it. And B would like to have only 6 electrons around it. So when they become with the structure, you'll find if we have BF3, if we draw the Lewis structure for BF3, we will find that this is the structure for BF3. This means how many electrons around each fluorine? Look at the fluorine, how many electrons around it?
8.
8.
The other fluorine and the third fluorine, 8, 8, 8. But how many around the B?
6.
6.
Only 6. Is this acceptable? Yes, it is acceptable for BE because it's a special case. For B, boron. Is this clear? Same thing with BEF3. If you have the structure, this is the structure for BEF3. Again, how many electrons around the fluorine?
8.
8. And the other fluorine, 8. How about BE?
4.
Only 4. Is this acceptable? It is acceptable.
Yes.
What do we call these 2? We call them incomplete octet. Incomplete octet. Is this clear? Very good. Last thing I want to say is let's get this away. So we have 3 exceptions. Okay. Now, last thing, let's do the structure of S. Okay. Look at your periodic table again. Look at your periodic table. At the top, you have BE, and then B. I'll talk about main group only, non-metal for B. And then what after B? You have carbon. What after carbon? I need help. After nitrogen.
Oxygen.
After oxygen.
Fluorine.
Fluorine. And then?
Neon.
Yeah.
I mean, yes. Okay, and then after that, neon. Very good. Now, I want to tell you that how many electrons BE would like to have around it? 4 only. How about B?
6.
Carbon, nitrogen, oxygen, fluorine would like to have how
8.
many? Apply them to cool. All of them. And of course, neon also already have 8. So that's why it doesn't make any bonds. Is this clear? But when you go to the elements below them, like for example, if you go to silicon, and then under nitrogen is phosphorus, and then sulfur, and then chlorine, and then bromine, and these things, these elements in the second and third row can take more than 8. More than 8. And we call this expanded octet. Expanded octet. This means we have more than what? The more than 8. That's called expanded octet. Let's draw the structure of. Let's draw the structure of. The structure of SO3 2-, which we did just a while ago. If we draw SO3 2-, I'll draw it very quickly for you, and I already did the Lewis structure. Okay, now let's talk about oxygen 1, oxygen 2, and oxygen 3. All right? Good. Now, how many electrons around oxygen 1?
8.
8. How many around oxygen 2?
8 also.
Also, how about oxygen 3?
6.
8.
Still 8. I'm not talking about formal charge, I'm talking about how many electrons. Okay, how about sulfur? How many electrons around the sulfur now?
8.
10.
10. 10. Is this acceptable? Yes, it is acceptable. Why? Because it's expanded octet. Can we do this if this is instead of oxygen, let's say it's fluorine? Let me tell you something else. So this is acceptable. Why? Because sulfur has 10 electrons around it, and this is called expanded octet. Expanded octet. Is this clear? Same thing with if I draw the structure of PF5. This is the structure of PF5. How many electrons around each fluorine? Quickly.
8.
8. All fluorines are 8. How about phosphorus? How many around phosphorus?
10.
10. Is this acceptable?
Yes.
Yes. Yes, we can do that. Okay, let me give you also another example. How about if we have S, F, 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 and then we have, this is the structure of SF6. How many around each fluorine?
8.
8.
8. How about the sulfur? How many around the sulfur?
12.
12. Is this acceptable? Yes, it is acceptable. Why? Because it's expanded. Now, let me ask you a very simple question. Can I have an F5 molecule? N, F, 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 F. Can I have this molecule?
No.
How many? The fluorine.
No.
No.
How many around the fluorine?
8.
8.
How about the nitrogen? How many around it?
10.
10.
10. Is this acceptable?
No.
No.
Because the maximum that can the group take in the first group is what?
8.
It's only 8.
So this is wrong. I hope this is clear.
Doctor,
Yes.
what if S with the chlorine to
Yeah.
expand octet?
Yeah, we can have, yes, of course. No problem. If it's S with chlorine, not fluorine, same thing. But in this case, what's the formal charge of chlorine? I mean, not formal charge. How many electrons are on this chlorine? All the chlorines. 8. And how many around the sulfur? 12.
12.
Very good. Now, okay, draw the structure of ClO molecule. ClO molecule. Can you draw the Lewis structure for ClO molecule? To start with, you have to count how many electrons we have from chlorine. How many in chlorine? Hello? What's the balance of chlorine?
7.
7.
How much oxygen?
6.
Total of what? Well, what's the total?
19.
Can you draw the Lewis structure?
No.
No,
Why
we
not?
can't.
Now,
Because it is odd number.
odd number. Then this means you cannot draw it. It will be like this. Very good. All right. How about let's draw the structure of Bi3. This is the structure of Bi3. Is this correct structure or wrong?
Correct structure.
Why?
Because B takes 6.
6.
It takes only 6, so this is correct. No problem. How about ASF4, like 5? Is this acceptable structure?
Yes.
Yes.
Because AS has,
It has it can take more than 8.
which is what? How many around it now?
10.
10. 10. Is this acceptable? It is acceptable.
Yes.
It's called what? What's the name?
Expanded.
Expanded octet. Very good. Okay. What's the name of this special case?
Incomplete.
Yes, incomplete.
So, doctor, if B takes 8, it will be wrong.
Yes. This, for B and BE, don't forget, BE would like to have how many? Only 4, and B
6.
6. If it take 8, it will be wrong. Exactly. Special cases. Very good. Last one is this one. Actually, if you draw the full structure, it will be like this. Now, how many around each fluorine?
8.
8.
8. How about the xenon? How many around the xenon?
8 also.
No.
10.
No.
12.
Why? 12 electrons. Look, 4 bonds. This means 8, and then I draw.
Yes. 4.
Here.
14.
12 electrons. What do we call this?
Expanded.
Expanded octet. I hope this is also clear. Good. That's the structures. I hope this is good. Now, bond enthalpy. Bond enthalpy. What's the meaning of enthalpy? What's the letter that we use for enthalpy? Huh?
H capital. H capital.
H capital, exactly. And we use delta to make it the change in enthalpy, exactly. The bond enthalpy, this means if you have hydrogen with hydrogen and all you break it to make it hydrogen gas plus hydrogen gas. What did you do in this case? What did you do?
You put it.
Break the bond.
Break the bond, exactly. So you took this bond and you break it. Now, whenever break a bond, delta H is negative, is positive. Delta H must be big positive. Now, if we say that in this case delta H, if it's X, then what's without, I'm not going to tell you, what's the sign that we can put here, plus or minus?
Plus.
Minus.
Plus. Why are you saying plus?
The break.
Always plus. But when you make a bond, delta H must be what? Negative. Clear?
Yes.
Okay. This means if I have H gas plus H gas to make H gas, and everything must be in gas, by the way. Delta H always, everything in gas. Don't forget this. Okay, what will be delta H for this one now?
Minus.
It will be what?
And minus.
Minus what? Minus X, because we said this is 1 plus X. This means this is minus X. Okay, let me give you numbers. Instead of this, I will say that H2 gas goes to 2H gas. Okay, delta H is equal to 436.4. Okay, is this going to be plus or minus?
Plus.
Why?
Because we break the bond.
Exactly. On the other hand, if I have 2H gas goes to H2 gas, what will be delta H for this reaction?
Minus.
Minus 436.
Minus what?
460. 36.4.
Is this clear? Right?
Yes.
That
Main.
example. Look at this. All of these reactions has been done and calculated the heat for this reaction like this. Okay? And we do it for so many things. Now, the enthalpy has been calculated for so many molecules. Look at this table. This is the bond enthalpy for hydrogen. This is bond enthalpy for HN, OH, HS, HP, and so on and so forth. So the values are here calculated for you. Is this clear? All right. And this is for single bond and double bond. Look at this one. For example, which one is stronger, single bond or double bond?
Single bond.
Stronger.
Double bond.
Double bond.
And which one is double or triple?
Triple is stronger.
So look at this one. What's the triple bond? CC, double triple bond, what's the value?
812.
And double bond?
600.
This is the enthalpy, Dixon.
Yeah, the enthalpy, yes, bond enthalpy. And single bond?
347.
And tell me what's the unit that we're going to use in all of them?
Joule.
Kilojoule per mole, or joule, of course. But usually they give you in kilojoule per mole. Joule is acceptable, but usually they give it in kilojoule per mole. Is this clear? Very good. Now, a chemical reaction. What's a chemical reaction? You imagine that you are breaking all the bonds and making all the bonds. Whatever you break, you're going to do what? Give it delta H positive or negative?
Positive.
Positive. Whatever you make, you're going to do it what?
Negative way.
Negative. Okay, so delta H is actually summation of bond energy for reactants, and we'll give it bond for reactant, because we are breaking all the bonds from the reactant, we'll give it plus, and we'll give minus for the product. Why? Because we are making the product and we are breaking the reactant. And I'll explain everything in this case. For example, if we have this structure, we have this reaction, CH4 plus 2O2 to give you CO2 plus 2H2O. Clear? I will make this a bi-Lewis structure. So this is the structure of CH4. This is the structure of O2, and they have two of them, 1 and 2. And then CO2 is C double bond O, C double bond O. And then H2O, I have this Lewis structure. So imagine that you are breaking all the bonds and making all these bonds. What are the bonds that you broke in here? To start with this one, what are the bonds that you break? You broke all the CH bond. How many CH bonds we have in this structure? How many?
4.
4. 1, 2, 3, 4. So we have 4 CH bonds. And how many bonds, how many double bonds do we have here for oxygen?
2.
2. Why? Because it's multiplied by 2 already. So this is 2 of them. Clear? Okay. Now, since these are broken and they are reactant, this means, are we going to put plus or minus for these bonds?
Plus.
Okay, we will go to the table. Don't forget, we need 4 times CH bond. This is the CH bond. Where is the H bond? This is CH bond. So how many we have? 414. Is this clear? 4 times 4, 14. And plus also 2 times, what are we should look for now?
2
Oxygen. What?
$498.7.
8.7. So I will write here 498 plus 2 times 498.7, was it? Good. What are the bonds that we made? Hello?
Yes.
What are the bonds that we made? Because it's product made. This is product, and this is reactants. How many CO bonds that we make? CO double bond.
2.
What?
2 double CO.
Good. And it's actually 799 for the CO. And how many we made? 2. What sign? What charge you're going to give it to this to the product?
Minus.
Minus.
Minus. Don't forget this. Okay. How many OH bonds that we made?
4.
2.
No, not 2.
4. 4. Yeah.
Oh, 4. And this is, are we going to give it minus or plus?
minus also.
And minus.
So 4 times, and the bond, you take it from the table, but I'll give it to you right now. It's 460. Now get your calculator and calculate delta H for this reaction. What's delta H for this whole reaction?
I think it will be minus.
Go ahead, calculate everything. I need an answer.
minus 784.
80?
84.6.
Yes, so it is 785. What's the unit?
kilojoule
Per
mole.
mole. Do you know how to do delta H for bond enthalpy? Is this easy?
Yes, easy.
Yes.
I hope so. And actually, with this, we finish the chapter. Very good. I hope it's clear. So this is very important, and I can assure you that there will be, in the next exam and in the final, there will be at least one question like this one, in which you have to draw the Lewis structure. You have to draw the Lewis structure, like what we did here. You draw the Lewis structure. This is Lewis structure. Don't forget Lewis structure. Then you count all the bonds, and whatever you break on the reactant, you make it with a plus sign. And whatever you made in the product, you make it with a minus sign, and you can calculate the total charge. I hope this is clear, and we finish the chapter this way. Okay, discard, and then I will first stop the recording. Stop the recording.